Good day all, and welcome once again to my channel. This time we are going to be having a video lesson on oxidation number concept. On the board we are having oxidation number concept. I'll be very quick about this video. Alright, so when we talk about oxidation number, what are we referring to? We are simply referring to the charge an element carries or possesses. The charge an element carries or possesses. So now there are some rules that must be obeyed for you to be able to name the IUPAC name of inorganic compounds. Alright, so now what are some of these rules that you must need to know in order for you to get the correct name of compounds? Now the rule 1 is the oxidation number, ON for short, of an element, the oxidation number of an element in an uncombined state. The oxidation number of an element in an uncombined state is 0. What does this mean? It means that when an element is not in combination with any other element, the oxidation number is 0. Alright, so classical examples include, if I write Na, sodium. Now oxidation number of sodium here is what? 0. Why? Sodium is not in combination with any element, it's just written on its own. If I write O2, that's oxygen, this still remains 0. Why? Oxygen is just there without any form of any other element. So hence, oxygen here, the oxidation number is 0, irrespective of the number here. S8, oxidation number of sulfur here is still what? 0. So long an element is not in combination with any other element, the oxidation number of such element is 0. That's rule 1. Then rule 2, the oxidation number of oxygen in most compounds is -2, except peroxides and superoxides, which is -1 and -0.5 respectively. Alright, so in any other compound other than a peroxide or a superoxide, the oxidation number of oxygen remains -2. Alright, so the rule 3, the oxidation number of hydrogen in most compounds is +1, except hydrides, which is -1. Now what are hydrides? Hydrides are simply compounds formed when hydrogen combines with metal or metals. Now it could be a single metal or more than one metal. Alright, such compound that is formed is called an hydride. Okay. Number 4, the algebraic sum of the oxidation number of elements in a compound is 0. Alright, meaning that when you sum up the oxidation number of all the elements that makes up a compound, it must give 0. And what does that mean? Now if I write H2SO4, this is a compound. If I sum up the oxidation number of all the elements here, which happens to be hydrogen, sulfur and oxygen, I must get 0. So that's the rule. Then rule 5, the algebraic sum of the oxidation number of elements in a radical is the charge on the radical. What are radicals? That's the question. Now radicals are simply compounds with charge, or I can say that radicals are a group of atoms that are controlled by a charge. Alright, so if I have something like this, NH4 plus. This is ammonium ion. This is a radical. So because this whole stuff is controlled by this charge, so hence this radical I must equate to the charge on the radical, alright, whenever I am summing up the oxidation number of the elements that makes up a radical. Alright, that's rule 5. Then rule 6. Rule 6. The oxidation number of a simple ion is the charge on the ion. And what does that mean? It means that when we say simple ions, we are referring to elements that carry charges. For example, if I say Na plus, Na plus is sodium ion. So this is a simple ion because it's an element with a charge. Alright, so now the oxidation number of this sodium here is equal to +1. Why? Because the charge that this ion is carrying here is +1. If I write O2 minus, the oxidation number of oxygen here is -2. If I write Al3 plus, the oxidation number of aluminium here is +3. So that is how it works. Alright, so that's rule 6. Then you can actually pause the video and take down this. Then we are going to look at the final rule, which is rule 7. Now the rule 7 has it that the oxidation number, rule 7, the oxidation number of group 1 and group 2 elements, with the exception of hydrogen in group 1. So in group 1, excluding hydrogen, alright, excluding hydrogen in group 1, the oxidation number of group 1 and group 2 elements are +1 and +2 respectively. That's when talking about when they are in combination with other elements. Alright, so we are going to look at questions that will clarify all this, and the questions we are about looking at are JAMB possible questions. So if you'll be writing the forthcoming JAMB, please don't dwell with these questions. A situation whereby you are given this compound KMNO4, you are given K2CR2O7, you are given SO2, you are given K4FeCN6, then probably you are given H2SO4. Now you are asked for the IUPAC names of these compounds. Alright, and don't forget the full meaning of IUPAC means International Union of Pure and Applied Chemistry. So don't forget that, International Union of Pure and Applied Chemistry. Now if you are asked to get the oxidation number of manganese in this compound, how would you go about it? Remember that when obeying the rules, this is a compound. Let's start with the A part, which is KMNO4. This is a compound, and then you must equate to 0. Remember, the algebraic sum of the oxidation number of elements in a compound is equal to what? 0. Now, potassium is a group 1 element, so the charge here is +1. That's the oxidation number of potassium here. Oxygen in most compounds is what? -2 according to the rule. Then we are told to calculate the oxidation state of what? Manganese, which is unknown, X here. So what are you supposed to do? Bring down this number, +1, then plus algebraic sum, we are summing, plus X, then plus, we are still summing. Then now you consider the value here, which is the number here, and then you have to multiply by the charge. So this number here, when you multiply by charge, it gives -8, being 4 times -2 -8 equal to 0. So when you do that, it becomes +1 still remains 1 plus X. Then when you open this bracket, plus times minus is what? -8 equal to 0. 1 minus 8 is what? -7 equal to what? 0. So that gives us what? If we want to get X, that should be X equal to 0 plus 7. If you move this -7 to the other side, we are going to arrive at what? +7. So hence, the name of this compound is potassium tetraoxomanganate 7. Potassium tetra, also, because of this word, this 4 number here. All right, tetra stands for 4. So tetra also, then manganate, then 7. The Roman numeral of 7 is VII. So you work with Roman numerals and not work with the numerical values. All right, so that's the name of this compound. Then what about if you are told to give the IUPAC name of this B part? K2 CR2 O7. This is almost similar to this first one. All you simply do, just equate to 0 because it's a compound. It does not carry any charge. Then potassium here is what? +1. Then oxygen here is what? -2 in terms of their oxidation numbers. Then while this chromium is unknown, you are told to find the oxidation number of chromium. How would you go about it? You have to multiply this number. See, the twist is this. Any element in a compound that carries a subscript number, you have to multiply that number by the charge. So in this case, if we multiply it, we are going to arrive at +2, which is +2 times 1 +2. Then while this number, you still consider it plus 2 times x is what? 2x. You understand? Then plus, instead of we even wasting time, we should just go straight. Plus times minus is minus. So 7 times -2 is what? -14 equal to 0. So +2 minus 14, that should give us -12 equal to 0. So when you move the -12 to the other side, it becomes 2x equal to 0 plus 12, which is you now divide both sides by 2 because 0 plus 12 is still what? +12. All right? So over 2 to get your x. So when you do that, 2 into 12 is what? 6. So hence our x value is what? +6. Hence the name of this compound. You have to be extremely careful now in naming this. The name of this compound is potassium hepta. Hepta stands for 7. Hepta also, then go of that 2, dichromate 6. All right, so it's not just potassium hepta also chromate 6, because if you ask this question most times in exam conditions, a particular option will be potassium hepta also chromate 6. But please, you must always attach that di to it, which is dichromate of these two. You must attach it. That becomes dichromate 6. So those are the IUPAC names of the first two compounds there. Then let's consider the other ones. The other compounds there. Now, considering the C, which is this guy. Now, the oxidation number of sulfur here should be what? Let's consider it. SO2. Now, oxidation number of oxygen in most compounds is what? -2. Sulfur is unknown in this case. So this is a compound. You equate to 0. What are you supposed to do? Just go straight. X, then 2 times -2 is what? -4 equal to what? 0. Then x is equal to what? When you move this one to the other side, 0 plus 4, which is what? +4. So this compound is called what? Sulfur 4 oxide. Sulfur 4 oxide. That's the reason why it's called sulfur 4 oxide, because this 4 here is the oxidation state of sulfur. All right, that's even the reason why CO2 is carbon 4 oxide. Why is it carbon 4 oxide? This is X and this is -2 equal to 0. When you still do it, it's similar to this. You get carbon 4 oxide. Then why is it that CO is called carbon 2 oxide? It's not because carbon here is X, then oxygen here is -2, so equal to 0. Now, there's no number to multiply this, so you just go straight. X -2 equal to 0. If you move it to the other side, X equal to 0 plus 2, which is +2. So that's carbon 2 oxide. All right? So that's how you go about it. Then, what about the D part? Now, this D, which is K4FeCN6. Now, potassium here, of course, this is actually a compound, you remember, so it must be equated to 0. Then potassium here is +1. Iron here is unknown, that's what we are told to find. Then this cyano group is minus. Just like when we say hydroxy group is what? OH minus. Cyano group is also minus. So what are you supposed to do? All you have to do here is just to multiply this one. It gives what? +4, then plus what? X. We are carrying out the algebraic sum. Then 6 times -1, because this 6 is affecting everything. That should be what? -6 equal to what? 0. +4 minus 6, that should give us -2 equal to 0. When you move it to the other side, x equal to what? 0 plus 2, which is +2. All right. So the oxidation number of iron here is +2. So hence, what should be the name of this compound? it should be potassium, then hexa stands for 6, hexa, then cyano, because that's the cyano group, Cn, then ferrite, then 2, midnight. Ferrite is actually of iron. All right, so that's the name, the IUPAC name of that compound. Then let's see the E. This ought to be the E now. All right, so let's look at the E, which is H2SO4. H2SO4 is an acid. Now you are told to calculate the oxidation number of sulfur here. This is X, this is -2, this is +1 because it's hydrogen, and most compounds is in +1 state, then equal to what? 0. So what are you supposed to do? Because this is a compound, that's why we are equating to 0. So in this case, you have to multiply this. That should give us +2, 2 times +1 is +2, plus X, then this should be what? -8 equal to 0. Then what should we get here? That should be +2 minus 8 is what? Is -6 equal to 0. So X will become what? 0 plus 6, which is +6. So that's the reason why the name of this compound is hydrogen tetraozosulfate 6. Hydrogen tetraozosulfate 6. Now, if you are a very smart student, you should notice something about that name, that I did not end it with acid. The reason why I did not end that with acid is because I started with hydrogen. Assuming I did not start with hydrogen, then I will end it with acid, meaning assuming I started with just tetraozosulfate 6 acid. All right, if you check, I started with hydrogen, I did not end with acid. Over here, I did not start with hydrogen, so I must end with acid. So that's just the background of everything. So if you are given multiple questions on this, just follow the rules and then you'll be able to get it with ease. If you know that this video, you find it interesting, invite your friends if they have not subscribed, so they will have to subscribe to learn more from this channel. All right, thanks for watching and remain blessed.